Okay, HHO Basics. It's become pretty apparent to me in all of the responses versus email and video responses and so forth that people don't really understand the basics of hydrogen. So this video will show you the basics and hopefully get you started, okay? HHO obviously comes from water. There's a molecular bond between hydrogen and oxygen that happens that creates water. By pumping electricity through that water, we break that molecular bond, and then we end up with two hydrogen and one oxygen atom that leave the water in a gaseous state. That's where you get all the bubbles from, okay? But to do that, the water has to be able to conduct electricity. So you can't just put distilled water or Aquafina or something into the container. So straight Aquafina or straight distilled water, if they're good quality samples, they won't have any properties that will conduct electricity, or very little. You'll get minor bubbling. You have to put something back into the water. So to do that, you can use something that's not hazardous, like sodium bicarbonate, which is baking soda. You can use KOH, which is potassium hydroxide. That's a really good electrolyte. It's really corrosive, okay? You can use lye. Once again, sodium hydroxide is lye, and so it's corrosive as well. You can just use tap water. See, the problem with all electrolytes, whether it's minerals like lime or calcium or whatever that's naturally in water, or whether it's sodium bicarbonate, is that it tends to change form when you hit it with electricity, so it leaves this scum on the water. There's also another factor in here, that's frequency. Normal electricity that we use in the United States is at 60 hertz. That's what everything that runs here in the United States is designed to run on, okay? The power supplies are all designed to convert 60 hertz. So therefore, what we have in our car is basically, it's DC current, but it's being created by a 60 hertz cycle system. If we turn the frequency up, then you can get clearer water and actually produce more hydrogen with the same amount of current. So buying yourself a optimizer board from, like, I use the ones that are from Southern Kentucky HHO.com. They make a really nice integrated board, and it's reasonably priced. And that you can sit there and turn the frequency up and really kick up the amount of hydrogen that this thing is putting out. You know, you can get those train modulators and all that, but most of those aren't designed to handle this kind of current. You're gonna run anywhere from 10 amps to 20 amps. And I'm going to tell you right now that 20 amps should be your max. If you're going over 20 amps, you're going to make far too much heat. Okay, the water is going to get really hot. It's going to be so hot, in fact, that you're going to get steam. So over 20 amps, you're going to get steam, and that's not good. You just defeated your hydrogen cell if you start making steam. Steam will defeat the whole purpose of the cell. You want gas, not liquid. And steam it's crude steam, so it's low temperature steam. It's a moisture product. Not only will it defeat your hydrogen fuel cell, but it will just make a mess in the tubing. You could get soaked air cleaner and all that. You don't want all that. We ended up putting, in the one video that I made, 2 stainless steel spatulas. That's a creative way to get people started in this process. I recommend you use a low carbon stainless steel. You can buy it sometimes in the hardware store. If you go into certain places and they have a hobby center, there's options to get high quality stainless steel. Wall socket covers are not low carbon stainless, okay? The problem is they have carbon in them. More carbon than I recommend you have for long-term use, and that'll start degrading, and the plates will get all rusty looking, and the cell gets nasty inside because it's leaching the carbon and impurities out of the stainless steel plating. So I recommend if you're really planning on keeping this long term, get yourself some quality stainless steel. There's a configuration here that works well. They're known as neutrals. Okay, people call them neutrals. There's going to be a lot of guys upset with me for making this video. I don't care. Is it NEU or any, well, whatever. Anyway, you know what it is. Neutrals. Neutrals are a plate that's just hanging in there. It's not hooked to positive or negative current coming out of the power source. Okay, and this is only going to work with DC too, by the way. I've had people try to hook AC up to this. That's not going to work. AC is it just doesn't work. DC only. Okay. So here we go. In a standard configuration with a one cell unit, no neutral. You got one plate that's positive. There's a spacer in between. In my video, I use that as plastic bolts and plastic nuts. The spacer has to be non-conductive. In other words, it can't be metal or anything that will conduct electricity. There are certain rubber gaskets that you'll buy that have lead in them. Those won't work. They'll cause a short. You have to have something that's not going to conduct electricity. If you're going to do this, the nylon works good. New nylon bolts. You can even use zip ties, okay? You can put zip ties around it, zip tie it all together. That gives you about a 1/16 of an inch. That's fine. If you don't want to buy bolts, you can do that, okay? So you're going to hook one plate up to the positive terminal of your battery, the other one up to your negative terminal of your battery. And instantly, if you have electrolyte in your water source, okay, you got to have an air gap too. I'm going to go ahead and just draw this in there. This is an air gap for the gas to collect. Instantly, you're going to start producing hydrogen and oxygen molecules on these plates. Positive plates produce oxygen. Negative plates produce hydrogen. The more negative plates you have, the better off you are. Okay, because the hydrogen is what we're after. We're gleaning that hydrogen gas out of the water. That's really explosive. That's what we want. It's really explosive, so you have to be extremely careful with it, okay? Neutral plates. If we take the same design, positive, negative, and we put a positive plate in, and then we take a plate that's not hooked to either positive or negative, it's just a blank plate laying in there. It's not got a wire coming off from it. And then another blank plate in there, and then a negative plate, and then a neutral, which is just a blank plate, no electricity hooked up to it, and then a positive, and a neutral, and a negative. What we've then done is the current that's passing through the water, that electricity is collecting on these plates. And it's making these plates charged without drawing any more current. These are actually not putting out as much hydrogen as what the ones that are hooked up are. But they do produce gas, and you want that, okay? Those plates will actually make gas without being hooked to anything because of the current bleed that's happening in the electrolyte. So now instead of taking this circuit right here, which maybe was drawn, let's just for instance say 5 amps. We've then utilized that 5 amps that's traveling through these other plates here. We didn't draw any more current, but we actually utilized that wasted electricity that's just kind of sitting in there, doing nothing as it's passing through the water. It's electrifying these plates and it's making hydrogen gas as it goes through. That's how these guys are getting the amps down lower, producing more gas without drawing more amps and keeping the water temperature cooler. There's a couple of other ways you can do that. You can actually put a water cooler in and a small pump to pump the water through something to keep it cool. The whole idea is to try to keep the water temperature down and keep your amps down at the same time. High amps cause your alternator in your car to draw more power. All it does is burn more gas to make electricity for your hydrogen cell. You just defeated the cell. You got to strike a balance there, okay? People ask me all the time, how much of this do you put in? How much of baking soda? How much this? I can't tell you that. Depends on your water. Depends on the quality of the metal you're using. Depends on the air gap you've got in between, the spacer, whether you use the plastic nut or zip tie, how wide that is. There's a lot of variables. You're going to have to buy an amp meter. You have to get a meter and you're going to have to learn how to use it. Okay? If you don't have an amp meter, then you're going to be playing around with this thing and just going to be trial and error, you know. That's pretty much the basics of the thing, and I I'll go in further here in just a minute on how to hook it up into your car.